When I dine out, people stare, ridicule, and put me down as I try to feed myself. But I spill food and drink on myself, which leads to more public verbal judgments. This was one of the experiences shared by our participant with Parkinson's disease. My name is Atharva Kashyap, and in this video, I will be talking about our paper titled Robot Assisted Social Dining as a White Glove Service. In this paper, we tackle three research questions. First, what type of human robot communication supports people with disabilities during social dining? Second, how should the robot behavior adapt across different social dining scenarios? And third, what should the robot's role be during and outside of mealtime assistance? To answer the research questions, we adopted a speculative participatory design methodology. In this, we conducted semi-structured interviews along with storyboarding using Speak to Scene, which is an AI-based storyboarding tool created and open-sourced by the research team. Overall, the procedure for our speculative participatory design study has 6 steps. First, we introduce the task to our participants, take their consent, and begin recording the study. We introduce terms such as storyboarding, AI, and speculative. Then we talk about the structure of the study. Once they are familiar with the expectations, we engage in trials to get them familiarized with Speak to Scene, our storyboarding interface. And since we want speculations to still be grounded in existing technologies, we introduce the Kinova robot arm that we expect to use for the feeding system. Once the introduction is complete, we ask them to create an avatar that is based on their lived reality with disability. The avatar is supposed to serve as the main character for the storyboard. Then, as part of the study, participants are asked to pick a scenario, for example, a date night or family dinner, for which they want to imagine using a robot assisted feeding system in a restaurant of their choice. They first create a 6 panel storyboard with different stages of dining. Throughout the storyboarding experience, we pose reflective questions to help with capturing ideas that might not have been captured through images. Once the 6 panel storyboard is generated, there was an optional break provided. Then we zoomed into 9 key moments within the 2 scenes of the storyboard, which are the eating and drinking. Some of these moments included prompts on the robot's role when they're waiting for food, or robot's behavior when they wanted to pass or share plates of food around with their dining companions. We again posed reflective questions as part of this to gain deeper insights into what the users preferred. Once the process of storyboarding and moments creation were complete, participants were asked to create a robot character, which essentially is how participants envision the robot to look and appear. While we provided a base image of a robot arm, participants still had creative freedom of how the robot arm looked. In the end, we conducted an exit interview where we asked participants to reflect on their study experience, provide additional thoughts, optionally keep a copy of the storyboard, and were compensated for their time and ideas. We had 6 participants with diverse disabilities who were recruited using the technique of snowball sampling. Our inclusion criteria stated that anyone needing any level of assistance with eating was welcome to participate. We conducted reflexive thematic analysis on the recorded transcript of the entire study session. This analysis revealed 3 themes, each answering one research question. Theme 1 outlined the necessity to create an interaction ecology or ecosystem in robot assisted social dining to foster a seamless human robot communication, answering the first research question. Theme 2 outlined the importance of ensuring that the robot possesses a context sensitive behavior when social dining, answering the second research question. And Theme 3 emphasized the importance of creating a robot that can support with self serving and sharing food during mealtime and providing assistance with navigation and payment outside of mealtime, answering the third research question. Within Theme 1, participants highlighted the importance of providing a diversity of modalities for users to interact with the robot. They also highlighted that the robot should be integrated into group dynamics, making it necessary to move away from the dyad of robot user to the triad of robot users others relationship. In Theme 2, we find that it is important for the robot to have an adaptable personality. Additionally, the robot should possess skills to perform shared table activities, such as performing a toast, at the command of the user. Lastly, participants highlighted the need for the robot to respond to users' symptoms rather than to their diagnoses or conditions. As part of Theme 3, our results say that participants want the robot to support with self serving and sharing food. Participants also highlighted that the robot could help with navigating within the restaurant and supporting with payment. Overall, we can synthesize our results using the metaphor of white glove service, which in restaurant settings is a personalized and detail oriented approach to provide hospitality to customers. White glove service has five key elements, and they are anticipatory assistance, discretion and privacy, personalization, attention to detail, and seamless problem resolution. And these are the principles that researchers can keep in mind when developing robots for social dining. And with that, we thank you for listening.